Java, let's get into getting closer and closer to actually programming. To be OO or not to be OO? That's the question that you've probably never asked, okay? So we have within programming two basic paradigms that allow us to implement our code. The first one is what we call procedural programming. Now, with procedural programming, what it is, it's a focus on the steps that we need to execute our tasks. So step 1, step 2, step 3, step 4, and so on. It goes in that way. Very much step 2 follows step 1. Step 3 follows step 2, and you're going, duh, David, duh. Yes, but we'll see in the next one. It doesn't always go that way. So the design of each step leads us to the kinds of data structures that we're going to need. What do I mean by data structures? They're the things that we use to store our data in when it comes in so we can process it. Now we have object-oriented, the other type of or other paradigm. Now in this one, what we're focusing on are the things, the entities that are required, okay? And we represent these within our algorithm, okay? What's the functionality each thing requires? So we might represent a car, a person. So what's the functionality that's required there? And how do we communicate everything within these things? So if you think of object-oriented as, in one sense, event-driven, think of using a word processor, okay? And you decide, let's block on a bit of text, and I want to bold and italics, or italics and bold it. Which one do you do first? Does it really matter? No, it doesn't really matter, okay? So that's with procedural, you can only do things in a certain order. In event-driven, object-oriented programming, we can do it in lots of different orders. And each entity that we create, we say is an object, okay? And once we've designed the objects, then we can work out what steps need to be required because we know what's there. Now, Java. So Java is an object-oriented language. Pretty straightforward. A guy by the names of James Gosling designed it, and he designed it as a small OO language back in the very early 90s, 1990, 1991. Now, if you're looking at this big diagram here and you go, what is that? You need to go Googling, okay? And you need to go home and probably talk to your parents about something known as the browser wars. And see if your parents remember the browser wars, okay? If they do, fantastic. If they don't, go Googling. So Java was initially designed and it was aimed for things like appliances. That was the original idea. So your toaster could be Java powered. But 1993, animation and interaction on the World Wide Web, that's where Java really went to. And when Netscape, if you notice the N for Netscape, so Netscape, when that opened up in 1995, allowing Java applets, what happened was Java became extremely popular. I mean, extremely popular. So we have to think through some of the possibilities or some of the ways that our code is designed and functions. So we have this one called interpreting. And I say the source code file is translated line by line into machine code instructions that the machine executes. All right? Whatever you say, David. If syntax errors exist, the program partially executes. All right, David, I'm not going to argue with you on that one. And you're still probably going, I don't quite get it. Well, I always think of an interpretation language. A good friend of mine, when we were living in Turkey, excuse me, she was the interpreter for the United Nations. So she worked at the United Nations and simultaneously translated English to Turkish, Turkish to English. So as I would be speaking, not that I was speaking at the United Nations, she would be interpreting or translating that one sentence, okay? As they went line by line, it was going. One line and it was interpreted. One line it was interpreted. So that's how I look at interpretation in the code. It goes line by line, okay? So things will partially exist when we run into errors, okay? So, but once we hit these errors, the execution stops. Python, Ruby, these are interpreted languages, okay? Now, interpretation is slower than compiled code, okay, because it needs to do the syntax checking and translation, okay, as it goes, while it's compiling and executing the code, all right? The next form is compiling. Compilation. The process whereby the source code file is translated into machine code, all right? So the source code is checked, making sure it conforms to the grammar rules and everything that's required. That's nice. And if there's no syntax errors found, then the machine code is created, okay, and it is ready to go. It's ready for execution. Now, with just one error, the machine code file isn't created. So compilation, I look at it like this. Another friend of mine has written several books, and her books she wrote in English have now been translated into, well, one of the languages they're being translated into is German. So what's happened here is we've taken the book and we've translated the entire book into a new language, and that book can now be executed by the German-speaking world, that is, read. That's compilation. So we compile our source files into an executable, and then we run the executable. Interpretation, we run the code, and it's executed line by line as it goes. And it means that when it's interpreted, sometimes things can partially run because it hits an error later on. When we compile, okay, the program has to be syntactically correct to compile, okay, and then it fully compiles. Now, Java, an independent platform, okay, so what do we mean? Well, what happens with Java, you say here it's achieved by running bytecode on the Java virtual machine, the JVM. So, bytecode is the Java virtual machine's machine code. So if you recall earlier I talked about machines understanding machine code. Well, what we've got is, let's try and draw it. I'll say we've got your computer, okay? And then the Java virtual machine sits on top of your computer. Not physically, but in the machine. And the bytecode is compiled to the Java virtual machine code. And then that can execute on top of your computer. So the Java compiler, what it does is it compiles from the source code to our bytecode. And now the Java virtual machine is actually a piece of software. And its job is it interprets and runs the Java bytecode. Pretty straightforward. Now, as I've said, each machine needs native machine code, so the bytecode is interpreted, okay, so it's interpreted in here by the Java virtual machine, and then the instructions get passed down to the local machine in the machine language that's specific for that type of machine. Pretty straightforward. So we say bytecode interpretation overheads is lower than the traditional interpreters conversion. Okay, so there's pros and there's cons, and we'll talk about that at the moment. But as you can understand, interpretation overheads occur, but bytecode interpretation, the idea behind it, and I think it comes in the next slide, is when it comes to Java, you write it once and then you can compile it and have it run on any of the different platforms. So, our traditional methods, we have our source code, and then we compile it, and we compile it to Windows, or to Unix, or to Mac. And then we've got a program that's in the machine code of the type of machine we're working on. So Windows, Unix, or Mac as the main ones, and then it runs. Straightforward. Now, Java, or the Java virtual machine, I say here, as long as local machine has the bytecode interpreter, it can download any Java program in bytecode and execute it. And what do we mean? Well, if I write my program in Java and I compile it, and I did that, let's say, on a Mac, theoretically, and I say theoretically, I can take that bytecode over to Windows, and provided I've got the Java virtual machine on Windows. It'll be able to run. And the same onto Linux, and you can imagine all the way around on those things. So what we say the source code is secure because we've got that source code, we've compiled it, we've kept it safe, and we've got our machine working. It also means that only one version of the bytecode actually needs to exist, because we can use that version of the bytecode and run it on any machine that has the Java virtual machine on it. So what are some of the good things? We say it's platform independent, meaning I can build it on any platform and run it on any other platform, okay? So our platform independent binary data, very nice. It's robust, okay, fairly robust. It does not allow operator overloading, and we'll come to that in another lecture, what that means. Java has a huge library, okay? And that library you can use, and it facilitates all kinds of things like file input and output. So you don't need to be concerned about that. You just call from the library what you need. Graphics, you can do all kinds of things. It can grab events, it can do all kinds of trapping and handling, and you're going, what is trapping and handling? We can do 3D modeling in Java. Phenomenal, fantastic. Java, the bad. What are some of the bad things about it? Well, the syntax is adopted from C, and once you do Unix and C programming, you'll see C, never mind, one of my favorite languages, but it's pretty ugly. Okay, so some of our control structures are primitive and are unstructured. Well, that's life. So I say relax, the good and the bad will make more sense as we go into it, all right? So don't be concerned about all the goods and the bads and the things like that. The more you get into it, and even today, I still learn more of the good and more of the bad about Java.